All right, we're on potential and kinetic energy at the bottom of page 5. In general, there are two different forms of energy that we talk about in chemistry, kinetic and potential energy. Kinetic energy is abbreviated with a capital K, capital E, which is indicated in parentheses in the handout. Kinetic energy has to do with motion. I'm throwing a baseball. I have molecules moving violently around. That would be kinetic energy because it's energy of movement, okay? Solids, which have particles that only vibrate in place or oscillate in place, have extremely low kinetic energy. Liquids have higher kinetic energy because the particles can slide over each other. They're free to move relative to one another, okay? Gases have the highest kinetic energy because gas particles can have completely unrestricted movement. They can completely go off in another direction, bounce off of a container, come back and hit each other, and they're a lot more free to move than liquids are, which are sort of restrained a little bit. Now, potential energy is abbreviated with a capital P, capital E, which is indicated in the chapter handout in parentheses, so you need to know it. Potential energy has to do with a couple things. Stored energy, which has to do with being stored in chemical bonds, and energy of position. So, what does that mean? Energy of position means if I've got a hill and I'm standing at the top of the hill versus I'm standing at the bottom of the hill, I would have more potential energy at the top of the hill than I would at the bottom of the hill. Okay? So if we're looking at student exercise number 14, which says, I've got a balloon filled with helium gas. I cool the gas from 25 degrees Celsius to negative 25 degrees Celsius, and I want to know the change in each of those that occurs. If I am talking about the kinetic energy of the gas in A, the kinetic energy would obviously be decreasing because as temperature decreases, then my gas is going to move slower. The particles are going to have slower movement, okay? In terms of motion of the helium atoms, they are not going to be moving as readily because the temperature has gone down, okay? Now, if we're talking about the law of conservation of energy, which is the next topic, this is really similar to the law of conservation of mass, which says that energy cannot be created nor destroyed. And something that you need to know here is if I put heat energy into a reaction to get it to go, it has to go somewhere. So here I'm putting heat in as a reactant. Heat is a form of energy. What's going to happen is this energy will be stored in the bonds of my product. Okay, so this is following the law of conservation of energy. When you put heat in as a reactant, this is called an endothermic reaction, which is given to you in your chapter handout. Okay, the other type of process is going to release heat energy as a product. This came from the bonds in substance AB. So I must have had energy stored in the bonds, and when I broke those bonds, I released it as heat, and it's a product. So this is an example of an exothermic reaction when heat is emitted as a product. Something else you have to know is I have more potential energy in the product of an endothermic reaction than the reactants because this energy is now stored here and potential energy is stored energy. In this example, I had more potential energy in my reactant because when I broke the bonds, I released it. So here I have high potential energy, here I have low potential energy in the product. Okay? Your chapter handout in the middle of the page gives you 6 forms of energy you should be familiar with. Heat, light, electrical energy, chemical energy, mechanical energy, which is energy of motion, and nuclear energy. What I would do is I would stop the video. I would take a look at student exercise 15, 16, and 17, and I would fill in your answers in pencil, and then check them with mine. For student exercise 15, I want to know if a chemical change or a physical change occurred, and I want to know if there was an increase or decrease in potential energy. So if we're looking at A, a glass bowl falls to the floor. Is that a chemical or physical change? That's a physical change. When it falls to the floor, it is falling to a lower position. That is a decrease in potential energy. B, a bicycle is pushed to the top of a hill is a physical change. When I push it to the top of a hill, that is a higher position, so I have an increase in potential energy. C, a mixture of hydrogen and oxygen gases explode with a bang when ignited, producing water. That's a chemical change, and since there was an explosion, I was releasing energy, and there is a decrease in potential energy. D, an electric current decomposes water into hydrogen and oxygen gases. This is a chemical change. This is the reverse of C. So since I'm putting electric current in, that is energy which will be stored in the bonds of the product. Therefore, this is an increase in potential energy. 16. Identify two forms of energy involved in the following conversions. A, radioactive emissions vaporize water to steam. Well, we've got nuclear energy, and then we have heat energy with vaporization. B, steam drives a turbine. Steam is heat energy. The turbine moving is mechanical energy. C, a turbine spins and drives an electrical generator. The turbine spinning is mechanical energy. The electrical generator is electrical energy. Student exercise 17. Is energy released or absorbed by butane when it burns? Okay, butane is the liquid that is in a cigarette lighter. So when it's burning, if you hold your hand up to it, it's giving off heat. So that means it must be an exothermic reaction. And during exothermic processes, we're releasing heat, so energy is being released.